All right. Second problem in circular motion. Doing a loop-de-loop on a roller coaster is certainly circular motion, but here we have a block sliding down a frictionless ramp. Question is, what's the minimum speed it needs to make the loop-de-loop? All right. Well, again, as always, in all physics problems, we start by drawing a picture. When the thing is at the top, right, we want to make sure it maintains contact. Contact would be the normal force, right? And there's going to be the force of gravity. And so those at the very top, it'll have a velocity this way if it's coming down like so, right? It enters the track here, it goes up. When it's at the peak, its velocity will be to the side, but the forces on it at the top will be a normal force down and a gravitational force down. Those two forces, those two forces, the gravitational force down and the normal force, become the centripetal force. And the idea is it has to maintain contact. So if it loses contact, it will lose the normal force. If Fn becomes 0, the block loses contact. So we need to have a speed so it doesn't drop. Basically what we're saying is if that goes to 0, what's the minimum force we can do? So Fg is going to be Fc. Because if that goes to 0, we're in trouble. And so let's figure out what's the minimum speed needed if that were really, 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 really close to 0. So Fg is mg, Fc is mac, but the centripetal acceleration is v squared over r. Mg equals mv squared over r. Ah, so nice. Mass on both sides of the equation. They go away. So you get G equals V squared over R. Rework this. V equals the square root of G times R. Well, this whole thing is 8 meters. So the radius is 4 meters. So V is going to be to the square root of 9.81 meters per second squared times 4 meters. V is going to be 6.26 meters per second. And that's the answer.